Now we're going to go over the answers to the conjugate addition examples. And what you were supposed to do here is write both the 1,2 and the 1,4 products for all three reactions. For all three, identify the kinetic and the thermodynamic products. And then just for the first one, write the mechanism. And these, by the way, are the same examples that are towards the end of my chapter 16 notes. So we'll tackle the first one first, since it's actually helpful to go through the mechanism to figure out the products, at least the first time. And so I wrote this down here. And what I've done is I've numbered the carbons from one end of the diene system to the other. And it really doesn't matter where you start, if you start from the left end and go to the right end, or vice versa. And because you're not really numbering for naming, but it's kind of a good way to keep track of things. So when the proton adds, the proton is always going to add to the one of the two ends. And in this case, it doesn't matter which end, because as I said earlier, I'm pretty sure the molecule is symmetrical. So I'm just going to stick it on the one that I called 1 for simplicity's sake. And now I've drawn the two hydrogens that were originally on that carbon plus the new one, and that's going to put a positive charge here. If this product were to get attacked, the chloride would go on carbon 2, and that would give you the so-called 1,2 product. If you look at the second resonance contributor, then you end up with this resonance contributor where the positive charge is now on this end carbon, and when the chloride attacks, you end up with the chlorine on the number 4 carbon. And so in terms of identifying these things, the product on the left is the 1,2 product, the product on the right is the 1,4 product. The 1,2 product, for reasons of proximity, ion pairing, speed, is always the kinetic product. And then the thermodynamic product is going to be the more stable of the two products, which in this case is going to be the 1,4 product. Because if you look at the carbon-carbon double bond, the carbon-carbon double bond is more substituted in the 1,4 product than it is in the 1,2 product. And I think that was everything we were supposed to do for that one. Number 2, I did up here. So number 2, we have a symmetric dyene. So it doesn't matter which end, whoops, that was a bad color choice. It doesn't matter which end I call 1 and which end I call 4, so I just started from the top. And now we're adding HBr. And so the 1,2 product is going to be the one where the hydrogen goes on carbon 1 and the bromine goes on carbon 2, whereas the 1,4 product is going to be the one where the hydrogen goes on carbon 1 and the bromine goes on carbon 4. And so I had already labeled these as the 1,2 and the 1,4 products. And in terms of double bond stability, the 1,2 product turns out in this particular case to be, obviously, it always is, the kinetic product. The 1,4 product, if we look at the two double bonds, let's try maybe a better color. If we look at the two double bonds, the 1,2 product has the more substituted double bond and is therefore considered the more stable product. So that makes the 1,2 product the thermodynamic product in addition to being the kinetic product. And therefore, we would just refer to it as the product because it's the product. And then finally, with the third one, scroll down here. Hopefully I'm not making anybody sick. Here we have a non-symmetrical diene, and the Klein book really doesn't particularly deal with that, but I'm just going to show you what happens. So you can number from left to right, which I did in orange, or you can number back the other way. Oops, I hit the wrong one there. Let me erase that and put it in the right place. All right. Or you can number back the other way. And so what I tried to do when I did this is I wrote both sets of 1, 2, and 1, 4 products. And since I had numbered the diene system in orange, left to right, I wrote those 2 products in orange. So hopefully that's somewhat useful. And then I labeled the 1, 2 and the 1, 4 products. And then for the purple numbers, I wrote the products in purple. And those are those 2 products. And then I labeled the 1, 2 and the 1, 4 for each. Different books treat this in different ways. Some books have you write all 4 products, which I did here, and then sort anything out. If you look at the 2 orange products, you can see that for the 2 orange-ish products, that the 1, 2 product is both the kinetic and the thermodynamic product, because the double bond is more stable, whereas with the purple set of products, you would have a scenario where the kinetic product would be the 1, 2 product as always, and then the thermodynamic product would be the 1, 2 product. What some books will do with this, as I said, let me try to highlight this in yellow. So the diene, as I said, I did not mean to do that. Let's try highlighting. So the diene is not symmetric. So what some books will do is they'll decide which end you need to add the hydrogen to. And as I said, Klein does not address this, and you are not responsible for it. But if you're curious, some books will approach this by deciding which of the initial allylic ions that you get as an intermediate is better, using the criteria tertiary carbocation, more stable than secondary, more stable than primary, because they're all allylic. You don't look at the double bond substitution here. For this scenario, yellow is not going to work very well. So for the carbocation stability, it's tertiary, more stable than secondary, more stable than primary, not the number of R groups or amount of substitution on the carbon-carbon double bond. And so here, if you add the initial hydrogen to carbon 1 to make the orange product, or the intermediate that leads to the orange products, you end up with a secondary carbocation and a tertiary carbocation in your 2 resonance contributors, and you can tell that because the chlorine ends up secondary and tertiary. On the other hand, if we look at the purple product, here again you've got a let's see, that hydrogen, oops, did the wrong one again, sorry. All right, so if you look at where the chlorine is here, the chlorine is secondary, here the chlorine is primary, so you have a scenario where you have secondary and primary. So what's going to happen here is you're definitely going to get more of the orange pathway. And in that orange pathway, the 1,2 product is both the kinetic and the thermodynamic product. So that would be your major product. The reality is you might see all 4 products to some extent.